Genetic research in recent years has brought to light a fascinating concept, and that is epigenetics. Epigenetics is genetic changes above or outside of the genes. So why do I have a picture here of Audrey Hepburn? As a teenager in Netherlands, she lived during a very difficult time during the Second World War that left her with some health problems that are thought to be from epigenetic factors, not from mutations. You've probably read this text in Exodus 20, punishing the children for the sins of the fathers to the third and fourth generation. I puzzled over what that means, but now we know what it means. This picture introduced an article in the famous journal of Nature, The Sins of the Father. Where did they get that title? The article described evidence for the process of epigenetics. Epigenetics involves changes from above or outside of the genes. DNA by itself can do nothing. DNA is like a hard drive in your computer. By itself, it can do nothing. It has to have a management system to tell it what to do. There are layers of genetic management above the DNA. They decide how the information in DNA will be used. This article described experiments with mice. The male mice were exposed to a gentle odor, the odor of peach blossoms. And when they were exposed to that odor, they were given a mild electrical shock on their foot. This was only done for a few times for 3 days. And after that, whenever the males smelled just that odor with no shock, they reacted very negatively. Then these males were mated with female mice, which had never gone through this process. They had babies. The babies were never given electrical shocks, but whenever they smelled this odor of peach blossoms, they reacted the same way their fathers did. These experiments show that influences that affect us can be carried on to our offspring and affect the offspring without having any mutations. Let's look at some other examples of epigenetic biological changes. I used to tell my students that blind cave animals like blind crickets or other creatures are blind because they had mutations that damaged their eyes. But since they're in darkness, it didn't matter. Well, that actually now is known to be not true. Blind cave animals do not have mutations that have destroyed the eyes. Their eye genes are perfectly good, but the epigenetic process has turned off their eye genes because they're not needed. Another illustration is changes in Galapagos finch beaks. As climate changes and this affects the available food supply, the finch beaks average larger or smaller. These are also not mutations. These are just epigenetic changes. The management system is controlling how the genes are used. Some experiments have shown that the average size of beaks on the Galapagos finches changes as the climate changes and thus the available food supply changes. These are now known to be not mutations, but just simply epigenetic changes. The picture here illustrates 3 different types of life cycles of salamanders. In A, the animal always lives in the water and it has external gills and a fin on its tail to help it swim. The one in B begins life in the water with gills and that fin, and then it moves onto land and loses the gills and the fin. In C, that's a salamander that always lives on land and it only has the gills and the fin in the embryo. It's now known that the difference between these is epigenetic. They have the same genes, the DNA is the same, but the epigenetic process manages how the DNA is going to be used and how it's going to be expressed and produces these 3 different life cycles. Darwinian evolution has to begin with random mutations. Epigenetic modifications, however, don't fit that description. Epigenetic modifications are beneficial changes, they are initiated by the environmental influence, and they are inheritable. This implies genetic foresight. Something in this process knows what is needed and makes these needed epigenetic changes. That is a worrisome problem for Darwinian theory. So how do evolutionary biologists relate to this? To answer that question, I bought the most recent edition of the primary evolution textbooks. These textbooks that you see, some of them never mention epigenetics. The word is never mentioned. Those are some of the older texts, so that maybe that is partly explainable. The others talk about it very briefly, of a sentence, either in a sentence or up to a page and a half, but they try to downplay it and portray it as not being important and not doing anything significant. They really are denying what has been found about epigenetics. These texts are a little bit different. These 4 textbooks are by evolutionary biologists, but these individuals recognize that epigenetics is here to stay, it's real, and they're trying to develop a new theory of evolution based on epigenetics. What we see here is a developing conflict within science. Many evolutionary biologists resist epigenetics. In fact, as one molecular biologist says, these evolutionary biologists are ignoring 3 decades of molecular biology research. A few evolutionary biologists recognize that epigenetics is here to stay. They're developing a new evolutionary synthesis based on epigenetics. In summary, epigenetics is a realization of new complexities in genetics, complexities that also point to a designer.